Humanity has gazed up at the enormous night sky for endless centuries, curious about the universe's many unanswered mysteries. Scientists proposed the Big Bang idea in the 20th century in an effort to explain the universe's beginnings, development, and expansion, but even with its broad acceptance, this theory is still unable to provide answers to some of the most important problems. These cosmic riddles have become even more complex in recent years due to new discoveries. For instance, in 2023, NASA's James Webb Space Telescope made a groundbreaking observation in which it discovered celestial bodies that seemed to be older than the universe itself. This revelation stunned experts and sparked a debate about whether stars could have existed for a longer period of time than James Webb's most recent discovery of the universe's age. This paradox calls into question our current understanding of cosmic events. Does this oddity suggest that a whole new universe model is required? This movie will address these issues and many more. If you want to be informed about the most recent advancements in the cosmos, don't forget to like the video and turn on the notification bell. The star HD 14283 is located in the constellation of Ai, about 200 light-years from Earth. The star's extremely high velocity, which is 4,483 kilometers per second, is what makes it particularly intriguing. This velocity offers important insights into the star's turbulent history, which began about 1 billion years ago when our Milky Way was still forming and it collided with a dwarf galaxy that was home to this particular star. However, the most astounding aspect of HD 14283 is not its speed but rather its age. This star is one of the oldest celestial bodies ever observed, earning the nickname Methuselah in reference to the biblical figure who, according to legend, lived for 969 years. Originally, estimates suggested that its age was an astounding 16 billion years, but more recent calculations have revised that to 14.46 billion years, with an error margin of roughly 800 million years. When contrasted with the current estimate of the universe's age, which is around 13.8 billion years based on studies of the cosmic microwave background, this disparity poses a serious conundrum and begs the urgent question, what is this enormous structure? Given what we now know, it appears unlikely that a star could be older than the universe itself. This contradiction has caused researchers to re-evaluate the precision of current techniques for dating the cosmos and stars, which has prompted more research into these cosmic puzzles in order to get a better understanding of this problem. Understanding the difficulties in determining the age of celestial bodies is crucial. It is difficult to pinpoint the exact age of stars like our Sun since they keep comparatively constant temperatures and diameters across billions of years. Astronomers examine minute variations in a star's color and brightness over time, then contrast these findings with theoretical models that forecast the star's life cycles. Astronomers have created mathematical formulas that enable them to estimate a star's age using a technique known as gyrochronology. One important indicator for determining a star's age is its rotation speed. Just as a spinning wheel slows down due to friction, stars gradually lose rotational speed. Methuselah, instead than wondering whether the star in issue might be more than 2 billion years older than its surroundings, we may approach this from a different perspective. According to current estimations, the star in question is certainly ancient. It is the oldest known star in the cosmos. If we were to compress the universe's history into a cosmic calendar where the Big Bang signifies the ringing of the New Year's bell, would it be possible that the universe is older than we previously believed? It would be difficult to comprehend the enormity of 13.8 billion years. Astronomers determine the age of the universe by analyzing light from far-off stars that formed hundreds of millions of years after the Big Bang while the universe continued to expand, creating the phenomenon known as red shift. Earth would only emerge toward the very end of December 31st, and human history would only span the last few seconds of the year. The age of the universe is currently estimated to be 13.8 billion years, but recent research from the University of Ottawa has put up an interesting proposal that suggests the cosmos may really be considerably older, at 26.7 billion years. Professor Rajendra Gupta, a physicist from the University of Ottawa, has presented a hypothesis that combines Swiss astronomer Fritz Zwicky's 1929 theory with new concepts in physics. His theory suggests that protons lose energy over vast distances in time, a concept that contradicts current data about redshift. Gupta proposes that by allowing this theory to coexist with the universe's expansion, we could reinterpret redshift as a hybrid phenomenon not solely attributed to expansion. This reinterpretation could lead to a new estimate for the age of the universe, potentially offering solutions to long-standing cosmological questions, some of which have recently arisen in the wake of NASA's findings. Paul Dec, a theoretical physicist, first presented the idea of evolutionary interaction constants and fatigued light theory, which are both expanded upon in Gupta's work, implying that some cosmic interactions may have changed over time. It's crucial to remember that our knowledge of the universe's age has changed over time. For example, in the 1920s, Edwin Hubble suggested that it was only about 2 billion years old, but later observations significantly increased this estimate, eventually reaching the current consensus of 13.8 billion years. Regardless of whether we consider human history to be 10 or 5 seconds, on the grand scale of cosmic time, it is evident that the universe is incredibly old. Its constant expansion forces us to reevaluate our preconceived notions about its age. At the same time, there are fascinating new discoveries about our own Milky Way galaxy, as recent measurements show that stars in the outer regions move much more slowly than their counterparts in other galaxies. There are a number of theories explaining this phenomenon. One is that our galaxy might contain an unusually small amount of dark matter, an invisible material that is essential to the gravitational forces of cosmic bodies. Another is that our knowledge of dark matter and how it is distributed throughout the universe may be essentially flawed. This conundrum results from information gathered by the European Space Agency's Gaia satellite, which has mapped the locations of almost 2 billion stars in the Milky Way. These observations have caused astronomers to reevaluate their models of stellar behavior, especially in the outer regions of the galaxy. Since the gravitational forces acting on stars are dependent on the total mass of the galaxy, the speed at which stars travel is a crucial factor in determining the mass of a galaxy. According to a recent study based on data from the Gaia satellite, the mass of our galaxy, including gas-dust stars and dark matter, is approximately 200,000 billion times the mass of our Sun, 5 times lower than previous estimates. This mass reduction may be caused by the unexpected decrease in visible material in the Milky Way, which may indicate less dark matter than previously thought. However, determining a galaxy's mass is infamously complex, and there may be uncertainties in the data from the Gaia satellite or the analysis techniques used. In the next years, technological breakthroughs and new space missions will probably provide additional insight into these urgent cosmic puzzles, and we will continue to keep a careful eye on these developments as new knowledge becomes available. With its unmatched capabilities, the James Webb Space Telescope is poised to keep expanding our knowledge of the cosmos. We are attempting to comprehend not just the age of stars or the universe itself, but also the complex dynamics of galaxies. The factors that influence cosmic development and dark matter astronomical study is still primarily concerned with the expansion of the universe, but when more information becomes available, we may discover that our previous theories were inaccurate or lacking. As our observational tools improve, we may uncover new facets of the cosmos that will contradict even the most accepted theories. One of the fundamental questions we must address is whether the laws of physics as we understand them apply consistently across all scales and times, or if there are unidentified forces or phenomena influencing how galaxies move and stars age. Scientists are realizing more and more that they may not fully comprehend dark matter, dark energy, and the basic forces. Each new discovery from distant galaxies to stellar remnants offers tantalizing clues about how the universe works, but it also opens up more questions pushing the boundaries of what we know. The idea that stars could predate the universe, or that the universe might be older than current models suggest, forces us to rethink our entire approach to cosmology. It could point to the need for new physics, new models, and perhaps even entirely new ways of looking at spacetime itself. It also raises profound Philosophical questions about the nature of existence and our place in the vast expanse of the cosmos. If these findings are confirmed, they would not only reshape our understanding of cosmology but also profoundly alter how we view the very fabric of reality. As the debate over the true age of the universe continues, it's clear that we are at the precipice of a new era in astronomical discovery. The coming decades could provide answers to questions that have puzzled humanity for millennia, whether it's the deeper secrets of dark matter and dark energy, or the possibility of older stars. There are still many mysteries in the cosmos that need to be solved. While the answers may not yet be known, the thrill of discovery is just getting started. Stay tuned for additional updates on these groundbreaking investigations and theories. The future is one of exploring hypotheses and ongoing improvement of our grasp of the universe. Maintain your interest, and who knows what new scientific discoveries we could make next. If you want to be informed about the most recent advancements in astronomy and space research, be sure to subscribe to our channel. To ensure that you don't miss any next updates as we go further into the study of the universe, click the like button and activate the notification bell. There is a chance for groundbreaking discoveries in the future. With its cutting-edge imaging capabilities, the James Webb Space Telescope is already starting to uncover amazing new information about distant galaxies, exoplanets, and other celestial phenomena, but this is only the beginning. As the Webb continues to probe the depths of space, it may uncover information that contradicts our basic comprehension of the fundamental processes of the cosmos. With fresh exoplanet findings in the habitable zone, one of the most fascinating parts of this continuing study is the hunt for planets that potentially host life. Even though these discoveries don't offer conclusive evidence of life beyond Earth, they raise the possibility that life may exist elsewhere in the universe. The discovery of even microbial life on another planet would have significant ramifications for science and philosophy, changing our perspectives on biology, evolution, and our place in the universe. Additionally, as we continue to investigate the enigmatic forces of dark matter and dark energy, the potential for finding extraterrestrial life has never been more promising. These enigmatic substances make up the bulk of the mass and energy content of the universe, but we still know very little about their characteristics or how they affect the structure of the cosmos. As a result, our existing physics theories are probably going to be challenged and improved. Understanding the true nature of dark matter and dark energy and how they impact the universe's expansion is one of the most important mysteries in modern physics. If researchers can solve these puzzles, it may lead to revolutionary new understandings of the essence of reality. In addition to these cosmic discoveries, another area of focus is the ongoing study of galaxy behavior and motion. Astronomers have been forced to re-evaluate their models of galactic dynamics after learning that stars in the outer reaches of our own Milky Way galaxy are moving more slowly than anticipated. This finding may indicate that our galaxy and possibly others may not contain as much dark matter as previously believed. If dark matter is not as abundant as we once believed, it could have profound implications for our understanding of gravity and the overall structure of the universe. This is a perfect example of how new data can force us to revise our theories and assumptions, sometimes in ways that challenge even our most fundamental ideas about the cosmos. Similarly, the discovery that galaxies may evolve in ways that we have not yet fully understood highlights the need for a more nuanced approach to cosmology. Could the universe be much older than we think? Are there elements of its history that we have yet to comprehend? These are the types of questions that scientists will continue to explore in the coming years as they gather more data from both existing and upcoming space missions. As these mysteries unfold, it's clear that our current models of the universe are not the final word. There is so much more to discover, and the more we learn, the more we realize how much we don't know. This sense of wonder and the ongoing search for answers are what drives scientific exploration and discovery.